This is the troubleshooting guide for RAYDENT 3D printer. The agenda includes causes and troubleshooting on print failures and finish-related issues. The first chapter is about print failure. Let's see the causes and troubleshooting on each situation. Number 1. If the printout is not on the build plate or VAT, you should check the LCD or LED, which is the light sources. And let me walk through with you the process. Click the setup icon on the top right corner and click the printer. Then an arrow will appear. Click the arrow to open the menu. Click the print option at the bottom and click OK when the setting change warning pops up. And if you look at the menu on the left, there is diagnosis. Click and you will see the LCD panel at the top. Remove build plate and VAT out of the chamber and then click on and visually check whether the RAYDENT logo is projected or not inside the chamber. If the logo is projected, both LCD and LED are operating fine. If the projected image is not a logo, but a broken image, there is a problem with the LCD. If nothing's projected, it could be either LCD or LED malfunctioning. For both two of these cases, please contact the customer support for the replacement. Number 2. When printout is not on the build plate and is attached to the bottom of the VAT, first of all, in all cases, remove build plate and the VAT from the printer and pour the used resin out through a filter prior to perform any actions. Now, as you can see in the chart, let's take a look at the causes and the actions. Should be taken when the print is off the build plate and attached to the bottom of the VAT. The first possible cause is the temperature of printer. Make sure that the temperature of thermometer on the front door indicates 18 degrees or higher before you start printing. Indicates 18 degrees or higher before you start printing. The second cause is residue from the previous print. If residue floats in the VAT, it will interfere the light partially, which leads to the print failure. Pour the used resin out through a filter, and if there's failed printouts attached on the bottom of the VAT, slightly lift it up from the beneath of VAT with clean finger and remove it with tweezers. The third cause is the clean condition of the acrylic. After removing VAT from the chamber, remove the acrylic plate with regular adhesive tape and check the contamination. If it is possible to clean with water, wash it and reuse it. If it's not possible, replace it with a new acrylic plate. And when you wash it, please be noted that the acrylic plate absolutely has to be cleaned with water only. If not, the surface will turn to blur and not being usable anymore. Highly contaminated acrylic plates may cause distortion on printouts. The fourth cause is the damaged VAT. Damaged surface of the VAT also affects the print outcomes. After removing the resins, check the condition of the VAT and replace it with a new one if it's damaged. The fifth cause is when the printer has low light power. If the light power is low, there will be not enough power to cure the object, which also leads to the print fail. In this case, the light power has to be measured and calibration should be carried out. Remove build plate and VAT and attach the light jig to the VAT position and connect the USB port while was connected to the printer. Open the device manager to check if the computer recognizes the jig. In the studio software, click the setup icon on the top right corner and click on the printer and an arrow will appear. Click the arrow to open the menu and click print option at the bottom. and click OK when the setting change warning pops up. And if you look at the menu on the left, there's Mask Map. Click on Generate and Auto Tune. And the light jig will collect printer's light intensity information after warming up for 2 minutes. Once process is done, click Save and the mask map light calibration is completed. The sixth possible cause is the 0 point on Z-axis. In Studio, go to Setup and choose the printer and click on the arrow and click on Print option. Click OK when the setting change warning pops up and go to Setup and click on Reset. Then software will guide you how to set up the G-point calibration in 3 steps. Step 1. Place the jig into the chamber and make sure it's firmly well placed. Once you're done, click Next. Then build plate will come down to the current default position. In Step 2, you can manage the height of build plate from the software. And when you do that, use 0.05 thickness specimen to determine the gap between the build plate and the jig. If the specimen barely goes through the interval gap, then you're all set. When you're finished modifying the interval gap, go ahead and click Test and click Next once it's done. Step 3. Remove the jig attached to the printer and click Done. Now the 0 point setting will change to the new calibration value. Click Set to save the edited calibration value. Number 3. This is troubleshooting when printout has half printing or support is disconnected in the middle. First of all, in all cases, remove build plate and the vat from the printer and pour the used resin out through filter prior to perform any actions. If there's failed printout attached on the bottom of vat, slightly rip it off from the beneath of vat with clean finger and remove it with tweezers. Now, as you can see in the chart, let's take a look at the causes and the actions should be taken. The first possible cause is the temperature of printer. Make sure the temperature of thermometer on the front door indicates 18 degrees or higher before you start printing. The second cause is either lack of support quantity or deleted essential support on the lowest spot. Go to Support and set the density to the default value 1.0 and generate and try to reprint. If you're not sure all the slices has been supported, you can examine with the print simulation bar on the right. If there is no support at the lowest spot, the area will be light cured and will float around in the resin vat as a residue. And it will interfere the light partially, which leads to the print failure. The third cause is when the resin is not sufficient in the resin container. It is good to check the amount of resin in the vat before you start daily printing. Even during printing, if you're aware that the resin is insufficient, filling the resin may be a way to prevent print fail. The fourth cause is residue from the previous print. If residue floats in the vat, it will interfere the light partially, which leads to print failure. The next cause is the cleaning condition of the acrylic. After removing vat from the chamber, remove the acrylic plate with regular adhesive tape and check the contamination level. If it's possible to clean it with water, wash it and reuse it. If it's not, replace it with a new acrylic plate. When you wash it, please be noted that the acrylic plate absolutely has to be cleaned with water and water only. If not, the surface will turn to blur and not usable anymore. Highly contaminated acrylic plate may cause distortions on printouts. The sixth cause is the damaged vat. Damaged vat also affects the quality of print outcomes. After removing the resin, check the condition of the vat and replace it with the new one if it's damaged. The seventh cause is when the printer has low light power. If the light power is low, there will not be enough power to cure the object, which also leads to the print fail. In this case, the light power has to be measured and calibration should be carried out. Click Setup in the upper right corner, select the printing in the left menu, select the resin you're using from the list, and add 0.2 to the time factor value and save at the bottom. Time factor is the multiplying irradiation time rate when the light is scattered. Raising the time factor will increase the duration of the light cure, and decreasing will decrease the duration of the light cure. More light cure time means better adhesiveness between slices. You can check the modeling status of printout by changing the time factor value in the same way as above. The next cause may be due to the 0-point setting of Z-axis. Click Setup on the top right corner of the studio. Select the printer and click the arrow. Click the print option at the bottom and go to Setup tab. And you'll see the 0-point setting value is entered as a number. And let me explain details how to adjust it with following example. First, print the 2 mm thick specimens out from the printer. And second, measure each specimen's thickness with the vernier calipers. The proper range is from 1.7 to 2.1. If the measurement is out of the range, find the thickest specimen out of 4. Next, apply the correction value to 0-point setting. In the example shown on the screen, if the thickest specimen is 1.4, the correction value will be minus 0.6. If the value of 0 point was 64.4, take away 0.6 and adjust it to 63.8 and click Set. As the 0-point setting value increases, the thickness of the printout will be thinner, and as it decreases, the thickness of the printout will be thicker. The second chapter is about print fitness. Let's see causes and troubleshooting on each situation. If the printout fits tightly or doesn't fit at all, you should check the print direction or parameter values. For example, this 2-unit implant bridge has support on the lingual side and the angle was almost 90 degrees from the surface level. For crowns and bridges, the recommended print angle is under 45 degrees between the occlusal and bottom surfaces. So I modified the bridge direction to 45 degrees and added support. After print, the bridge could have so much better fitness to the model. The angulation rule is same for the surgical guides, but then the inner surface should be facing upward. If the printout is well seated but the inside is tight, there are two possible solutions. First, click on Setup in the upper right corner of the studio and click Printing in the left menu. And adjust the thickness level to have more loosened fit by 0.5. Increasing the thickness level will make the print be more tighter. and decreasing the thickness level will make the print be more looser. Another way to make print more looser is increasing the cement gap in the CAD software. If the fit is loose, adjust the time factor and parameter value. If the light power is low, the fit of the prosthesis may be loose, so we recommend to adjust the time factor value. More light curing time gives more print shrinkage accordingly. In the studio, click Setup on the upper right corner, select Printing on the left menu, select resin you're using from the list, and add 0.1 to the current time factor value. Another way to make it more tighter is adjusting the thickness level value. Go to Setup in the upper right corner of Studio and click on Printing in the left menu and select the resin type at the top and increase thickness level by 0.5 and reprint to confirm the fit. Increasing the thickness level will make the print be more tighter. Decreasing the thickness level will make the print be more looser. If you decrease the cement gap from CAD software, the fit will be more tighter too. And this was the RAYDENT 3D printer troubleshooting guide. Please contact our customer support team for additional issues, and we'll be happy to assist you. Thank you.